So for this project, our necessary components are as follow. We will need a breadboard, as you can see right here. We will be using a 330 kilo ohms resistor, a 100 kilo ohms resistor, a 9 volts battery alongside its cable, a power supply unit, which we'll be using to power up our whole circuits. We will also be using jumper cables. We most fundamentally need our LDR sensor, such as this one. We also need our LED, which, as you can see, we'll use a blue color for experiment. And lastly, we will need a transistor, which is this component. Okay, so first of all, before we can do any of our circuit configurations, we must make sure that we connect our battery with its snap-on connector to our power supply module unit. This unit will give power to our breadboard, and so that our LED and all our circuit is powered up. To do this, we first need to make sure that this positive and negative sign are aligned in correlation with our positive and negative signs on our breadboard. And just like this, we must set this up. Next, we will begin our first configuration, which is our series configuration. So to do this, we will get our 330 kilo ohms resistor, and we will introduce one of the legs to the positive side of the circuit back here, and the other one is gonna be at the middle of our board, as you can see here. So we set this up just like this. Next, we grab our LED just like this, and we make sure that the longer leg is gonna be positioned on the same aisle as our resistor on this side, and our negative leg is gonna jump to this section of our breadboard, just like this. Lastly, we will get our LDR, and one of the legs will be positioned on the same aisle as our LED and resistor, and then the other leg is going to be connected to ground. Now we can power this up, and we'll see that our LED is turned on. So what this circuit does is that whenever light does not shine upon the LDR, this LDE will shut down, will turn off, as you will see once I place my finger on top of the LDR. So here, the finger is placed, and it might not shut down entirely. However, if I take it off, it turns on immediately, since the light is shining upon this LDR. So here's another example, and that would be it. Next, we will configure our circuit in a parallel configuration. To do this, we will use the same components: the resistor, the LED, and the LDR. First, we will set up the 330 resistor, and we will set it up at a positive end right here. However, this leg will jump all the way to this side of the breadboard, not this side. We're doing this with the whole purpose of not using jumper cables. So There you go. There's the resistor, as you can see here. Now we grab our LED, and what we do is that our longer leg would go on the same line of the resistor on this part, which is the positive leg, and the shorter leg will go to the negative end on this side. So here it is. As you can see, now our LED is turned on, and now we grab our LDR, and one of the legs will go on the same line that is on the resistor and the LED, and our other leg will go to ground. Now here the LED is turned on since it's kind of dark. However, if you shine light upon the LDR, you will see that our LED will turn off. So here we go. I don't know if you can see that, but our LED is completely turned off. And now if I turn it off, then the LED is on. It's kind of hard to see, but that's the whole gist of it. This last one is going to be the transistor configuration. So for this configuration, we will need a transistor which has 3 legs, a 100K resistor, a 330K ohms resistor, our LDR, as you can see, another LED, and we will be using jumper cables this time. So first of all, we will grab our transistor, and since it has 3 legs, we need to position each one of them in one of the little holes of our breadboard, and all 3 must go in just like this. Next, we'll grab our 330K resistor, and we will have one of the legs on this side of the breadboard, this one, and the other one go to positive up here. Now we grab our LED, which we have to set up on the same line as our 330K ohm resistor, and the positive leg will go on the same side of the resistor, and our negative, which is the shorter leg, will jump to the other side of the breadboard, just like this. Now that we have this, we will use one of our jumper cables, and we will set it up from the same line, same line of our LED, with our first leg of the transistor, the very first leg to the left. Next, we grab another jumper cable, and we pinch our third leg, the third leg, which is gonna be on the right, and we connect it to ground, which will be negative on this side. And then lastly, we will need to have our 100 kilo ohm resistor go from positive to this side of our breadboard. I'm having a bit of trouble. Okay, there you go. Then we grab our LDR, and we jump from this side of the breadboard. One of the legs will go on the same line in this side of the breadboard, and the other one is gonna go back here. And lastly, what we will do is we get our jumper cable, and we connect the middle leg of our transistor with the section, the junction from the LDR and the resistor. And as you can see now, our LED is gonna be shining light. Now this is gonna be similar to the parallel configuration, since whenever you shine light upon the LDR, the LED is gonna turn off. So here, as you can see, shine is being blasted upon the LDR. So that would be it.